to all my friends and Assalamualaikum to all my friends and lecturer. Today I want to present the spiral heat exchanger. My name is Aiman Danish bin Kamsol. Matrix number 33DPE19F1121. The subject is DGP 30122 heat transfer. Firstly, the working principle of heat exchanger. Heat exchanger facilitates heat transfer from one medium to another. Often these media are two process fluid streams such as oil, water, steam, gas, air, and many more. In general, one fluid has to be significantly hotter than the other. Heat exchanger channels the flow of hot and cold streams through passage separated from each other by metal surface. Thanks to the high heat conductivity of the metal, heat flows from hot stream to the cold one, so the hot fluid exits the heat exchanger a little colder, and cold stream goes out a little hotter. That is why heat exchangers are widely used for heat up or cooling down a fluid stream in a processing plant. Next is the log mean temperature difference method. The logarithmic mean temperature difference, also known as log mean temperature difference (LMTD), is used to determine the temperature driving force for heat transfers in flow system. Most notably in heat exchangers, the LMTD is a logarithmic average of the temperature difference between the hot and cold feeds at each end of the double pipe exchanger. For a given heat exchanger with constant area and heat transfer coefficient, the larger the LMTD, the more heat is transferred. The use of the LMTD arises straightforwardly from the analysis of a heat exchanger with constant flow rate and fluid thermal properties. The formula of the LMTD is shown in the figure, where difference TA is the temperature difference between the two streams at the end A, and difference TB is the temperature difference between the two streams at end B. With this definition, the LMTD can be used to find the exchange heat in a heat exchanger. The second equation is Q equal U times A times LMTD, where Q is the exchange heat duty in watts, U is the heat transfer coefficient in watts per Kelvin per square meter, and A is the exchange area. We must note that estimating the heat transfer coefficient may be quite complicated. Next is the working principle of heat exchanger. A spiral heat exchanger is composed of two long flat plates wrapped around a mandrel or center tube, creating two concentric spiral channels. The hot fluid flows into the center of the unit and spirals outward toward the outer plates, while at the same time the cold fluid enters the periphery and spiral inward, exiting at the center. This is the example of the spiral heat exchanger. The first picture is the cross section of the spiral heat exchanger, and the second picture is the spiral heat exchanger device. Next, we have the spiral heat exchanger construction. First, counter current spiral flow. One fluid from center to periphery, the other from periphery to center. Co-current flow by reversing one of the sides. Channel spacing is flexible between 1/4 to 1 inch. U is valued 2 or 3 times that of a shell and tube. Next, the channel closure by bending and welding one edge. Cover gasket seals on each side to prevent bypass and leakage. We can see that the 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 thing on the circle is the channel closure, and the silver thing is the cover gasket. Next, we have the spiral heat exchanger components. Spiral plate heat exchanger are built by rolling two parallel long sheets around a central bar to make a spiral shape. The free final edges of channels then will weld together to seal the end of channels. The distance between metal sheet is kept using studs that are welded to the sheets. Next, we have the advantages. First, it is a first the spiral heat exchanger is a compact design. Second, it is a perfect counter current flow. Third, a small driving temperature differences of heat transfer. Turbulent regime at low Reynolds numbers than in plain channels. And lastly, it has low fouling. The disadvantages of spiral heat exchanger is it has a pressure limitation. Second, the thermal expansion and deformation of the plates at large temperature differences. That's all from me. Aiman Danish Kamsol from DPE 3D. Thank you for your attention.